first thing we should know about guitars is, first of all, what are we looking at when we want to figure out how they work. I know that when way before I ever started playing guitar, I never actually looked at one and realized that the most important things are like right here. Like before, I just kind of saw like a block of wood, and I had no idea how the guys got like notes out of it or anything. But so, anyways, first of all, in the blue we got the pickups. That's a thing that'll pick up the sound coming off the string. Volume and tone controls are those little knobbies there, and then the selector switch. Or Strat, this is what it looks like right here. It's just like a little a knife switch. And like different guitars, I should have put more pictures of different guitars on here too. Usually they'll have like a toggle switch or something similar. And yeah, so that's the basic setup for most guitars. And this is what the actual schematic for a guitar, or specifically for a Stratocaster, looks like. Typically, you have your pickups here, which are represented as inductors, because that's essentially what they are. You have a big selector switch right here, and that goes into a volume pot here, and your tone pots here, which are also selected along with the pickups at the same time. So first of all, the pickups work off of a function called Faraday's law, where if you ever have like a magnetic field that's changing in time, like it's pulsating or moving through space or something like that, it's going to create a voltage inside of a circuit, maybe like a wire or an inductor or a whole like circuit, like an amplifier or something. This is a separate issue, but that's part of the reason why you'll get like noise from like wireless sources and stuff. Like if we take Faraday's law, looking at a time-changing magnetic field, and we have a circuit like our guitar pickup is, you have the vibrating string, and these strings are magnetic. So that's what's acting as our changing magnetic field in time. There's a circuit component called an inductor, which is basically just a wire wrapped around a lot of times that picks up this magnetic field and through induction turns it into a voltage. And that's actually what the guitar signal is. And then that goes to the selector switch, which then just sends it to volume control, the tone circuits too. And I guess I should mention this. If you look at this here, basically our signal's coming in through the pickup, and then comes in down here, and then it goes through the switch, and it goes to the volume control and the tone controls at the same time, so they're in parallel. This is the setup for a Stratocaster, but there's, for like a Les Paul made by Gibson, or usually, I'll just say that again. The Les Paul has a different setup where each pickup has its own tone circuit already attached to it, so they're actually, goes like the pickup and the tone, and that's in series with the selector switch, volume control. So yeah, this is just one setup for one kind of guitar, so it does very good. So yeah, that's pretty simple. There's also a tone circuit inside the guitar, and again, that is these two potentiometers. What's happening is you have this potentiometer, which you could treat as, if this is what the symbol looks like, you can actually treat it as like two resistors. And then you just have a node in between them. As you turn the pot, this value of resistance will change at the same time that this does. So this will get smaller as this gets bigger, or vice versa. And what they actually did here was they only connected the signal to one side of the pot, and then the other side is just left untouched. What's happening is as you turn the knob, you just have one resistor that's getting bigger or smaller. And that is actually part of an RC circuit, which I was mentioning here. If we look at this in that way, say our signal is coming this way, then we have a resistor that's changing, going into the cap like this. So that's just simply a it's an RC low pass network. Depending on your incoming signal, you're going to have like a certain frequency, like low frequency or high frequency. And what's going to happen is higher frequencies are going to cause this gap to become short, and they won't actually make it to your volume pot and to the output of your signal. If you map a response to this, you'll get this kind of it's actually called bogey plot, where at 0 dB or unity gain, frequencies up until a certain point are cut off or are allowed through, and then at the cutoff frequency, they start getting attenuated. And that's actually a function of the resistor and the capacitor in the circuit. So now if we look at this and we say that our resistor is changing depending on its position, or depending on the knob's position, this frequency corner actually moves like left or right. And so what's happening when you turn down the tone knob, technically, is that your resistance value goes up. Yeah. The resistance value goes up on the bottom here. So then your frequency that everything's cut off goes down. And this actually moves to the left. Here is more bassier sound because all the treble's getting busy. Yeah. One thing, or a couple things I want to talk about that I didn't actually make slides for, was there's a whole bunch of factors that go into guitar tone through each of these sections. One huge factor is the actual selection of your guitar pickup. And the reason for that is because on there they're modeled as inductors. But what's really happening is that you have an inductor like this, but then there's so many windings in the guitar pickup that usually a wire has like really low resistance, but because there's something on the order of like 6,000 to 8,000 turns usually, that like builds up a lot. So this could be on the order of like 6.8K, which is a good deal of resistance. Then you have like some resistance, some inductance here. And then you also have like capacitance between all the windings. Because if you think about it, if we have a wire that's wrapped like this 6, 7, 8,000 times, if we like look at one little section here, we could say that, okay, now there's like all these little pieces of metal next to each other, but there's some separation between them. And so if you have current going on these little wires and they're all really close, then there's going to be some capacitance, right? So that's where this factor comes in. And anyways, the reason why two pickups that are wound the same, or two pickups can have different sound because of these two factors as well as this, because you'll get a frequency response that's different depending on those components. So now, then when we say at higher frequencies, what happens is the inverse, where this inductor now, all right, I should actually bring this too. So these are actually the relationships for frequency for an inductor and a capacitor. So basically, when frequency goes up, or when omega goes up, you're going to see a resistance, or an impedance actually, here that's getting bigger and bigger as frequency increases. And then the opposite is true for a capacitor. And so, looking at that simply, this goes from looking like a short at low frequencies to looking like a bigger and bigger resistor as frequency goes up. And then the cap looks like a big resistor for low frequencies, but then as frequency increases, it gets smaller and smaller. So it starts to turn into a short. What happens then is things start to roll off as frequency goes up. So again, it's like an LC. So at high frequency, this is like an open circuit. And this is like a short circuit. So you can kind of say that like no signals are going to make it through, and that's how it rolls out. It's very similar to the tone circuit in the too. But the issue is that this inductance is a different number, this resistance is a different number, and this capacitance will be a different number too for for your circuit and for the pickup itself. Different guitar pickups will have different values for these things, and that'll cause like a different frequency response, basically. One other thing too, in your tone circuit, one thing you can do to change the tone is you can mess with like these values of potentiometers, and this value of what a lot of guys will do is say when they roll down their tone, they want like a real bassy sound. They'll get like really large value pad, like a 0.1 micropad or bigger, but usually 0.1's as high as you go. Humbuckers? Yeah. Humbuckers. There's actually so a single coil like Stratocaster like on there is usually just like one pickup, right? What a humbucker does is they add another one, and then they actually put it in series. Usually, well, like Fender sometimes will wire these in parallel, so it'll be like these ends are connected. But then Gibson usually wires these in series. And one thing I should mention too, depending on how you wire pickups together, that'll change your frequency response too. Yeah, because if you think about it, if there's like an R component and a C component in here too, then you're either putting the R's and C's and L's in parallel or in series, and that'll change how the frequencies are affected. Normally with single coil pickups, you have this 60 hertz hum, which I guess would come from the being plugged into the wall and everything. What they do with humbuckers is that they'll have these coils that are oppositely wound next to each other, and that causes bass cancellation. And part of what bass cancels out is a 60 hertz hum. And so humbuckers are actually pretty quiet. But again, your frequency response is different because of the way it's set up. And I guess if you actually looked at it, usually humbuckers sound like more bassy or thick sounding, and then the reason for that is if you have two of the single coils I previously mentioned that have a lot of resistance and everything, now you're like doubling that basically, and that's going to change how your curve comes out and where the cutoff frequencies are and everything. One thing I should also mention too is that, like Hutton was saying, there's also like really big variations on these too. Like you could have active pickups that have an amplifier built into the pickup before it even reaches the actual guitar amplifier, and that'll change the sound quite differently. One thing is that it'll give you a lot of headroom, and that's why they say the active pickups sound just louder, because they are actually louder. The electric side, it's mostly a physical thing. If you think about it, if you have a guitar body and you have pickups set in certain places on the body, so you have like a pickup here. What? Don't laugh at me. So let's say you have a pickup here closer to the neck and one that's closer to the bridge. The reason why they'll sound different is, I guess, simply because there's more string vibrating. Like if you look at it, if your string starts here and goes there, the place it's gonna like vary the most is in the middle of the string, right? If you have a string that's like planted between 2 points, it's gonna vary the most like this, or like it's gonna have to taper off at the planted points. And physically, your guitar neck is like, if you're holding down a note, say like this point, or say this was the length of the string, if you're holding down at this part of the string, there's going to be certain frequencies on this length, and maybe a bigger ones over here, just due to the length of the string itself.
Yeah, so the thing is that you don't know what you said.
Yeah,
but that's your overtone. If what you want is that slower rhythm, then you want to emphasize that up on that side. But if you
only have pickups on one side of the string, that's the problem. Yeah.
The vibration that's happening on the other side of your hand is
Yeah, that's the part that, you know, doesn't pickups.
But then if you're capping the bonus, like if you don't mute the lower half while you're capping, you still feel it.
I mean, like cables.
Yeah.
That's not possible.
It's not just
Is it
like
talking about
one
floor?
piece.
No, that's just.
Well, I guess it's mostly how many harmonics are captured at this point than this point. And one thing that's important to know too is closer to the bridge, the strings are going to be tighter and they're not bearing as much because of the playing down. And so you get more of a twanging sound. And so if you put a pickup there, not only are you going to hear twanging sound with your ears when you come to the guitar itself, but also with the pickups. The guitar itself influences the vibration of the strings, right? And
that's always.
yeah, and that's what's sent to the pickups. Yeah, but the pickups can only pick up what's vibrating on their side, I guess you could say. Okay. Any other questions? All right, well, that's my talk.